So let's look at 2 times 3. What is it? I don't know yet, right? But you might guess it very easily. But I need to prove exactly what that is using category theory. That's the point of this video. So let's establish our environment. I'm just going to use category of this. So it's a category of finite sets and all the functions between them. And in this category, the terminal objects, what I'm going to use is the simplest one. It's a singleton. It's a set of a single object. It's the most valid object, right? You know what I mean? So how do we actually build numbers out of it? I'm just going to use something this. It's a coproduct. It's a coproduct just a disjoint union in set. So the number 2, 3, they're just really simple. What I mean is basically 2 can be rewritten as the isomorphic class. So like this, 3, like this. You bet. So yeah, 2 is 2 terminal objects together. 3, 3. And what about this? Yeah, in our context, it's going to be our category of product. So this is a Cartesian product. Essentially, we can rewrite 2 times 3 as basically solving this problem. Now, here's where things get real. We don't actually have to guess how to expand this, because we are going to use this category of properties. This is a Cartesian closed category. What that means is the functor taking the product. So let's say the functor, let's say any random set A, is left adjoint to exponential functor. So, and as you probably already know, left adjoints preserve colimit, and coproduct is the colimit. So this means our product distributes perfectly over the disjoint union. So for any objects, the distributivity law literally is like this. So I'm going to take this entire left block, the 2, and I can distribute it to each of these 3 terminal objects on the right. So let's write out what that actually looks like. So we get, and same thing 3 times. Now look at what is inside these new parentheses. We are taking the categorical product of a set with this, and this is a terminal object. So terminal object is basically the identity for the categorical product. So it's going to be like this. So basically we can simplify this. So each of these 3 is going to be just this, and we can remove these parentheses, and we're going to be left with, and as you probably already know, this is an isomorphism class of this. So 2 times 3, 6. Simple, isn't it?